Just want to show you guys picking up some transient fields from my Arduino here. And so I added this 100 turn pickup coil going to this full bridge rectifier, which is connected to the AC side. I have a small 1 nanofarad capacitor going across the AC side to make this more of an LC tank. And then I have across the DC side this small 50 volt electrolytic capacitor that is 10 microfarads, and then I'm measuring the current using this across this 10K resistor, measuring the voltage using this from the Arduino. I was pulse width modulating this using this black wire onto this side of the AC coil just to measure the effects. But right now it's not being pulse width modulated, it's not connected, and it's also not programmed. I took the programming and made comments, turned all the PWM code into comments to see if that was affecting it. And so yeah, check this out. We're just picking up some transient fields up to like 45 volts there. And if I were to go to the serial monitor instead, this is displaying power output. So let's stop that auto scroll so you can see 0.01 watts, 0.02 watts is just sitting there from the environment. So that's kind of cool. The current's obviously super small, like as expected. We're not pushing any current through there, really. We're just like measuring it. There's a tiny, tiny amount. Um, anyways, I think that's kind of interesting. And then we'll go ahead and up. Okay, so it's uploading this now. Done uploading. So now what we're doing is we're just doing pulse width modulation at 99 and 150 hertz, and we're just doing that for 5 seconds each, letting it stabilize, and we're printing voltage, current, power, and we're just going to see what that looks like. So as you can see, it's a little bit different, but it's following similar waveform, especially this smaller waveform, which is pretty interesting. Oh wait, of course it is. The PWM's not even hooked up. Okay, now that's hooked up. Now check this out. Tools, plotter, boom. Whoa, completely different. So now it's kind of like a heartbeat from this PWM. And we're getting these spikes up here. If I were to go and monitor this, stop the auto scroll. So our peaks are around 51 volts, 52 volts, which is not as good as it was earlier at 54 volts with my other tests. So I think 54 volts with how it's set up is kind of where it's going to start maxing out with how it's set up right now. But getting pulses of 0.03 watts from the ambient environment every once in a while is not so bad. Alright, I just changed this frequency to 100 hertz and then changed the PWM duty cycle to 50%. And as you can see, we're at 0.03 watts and we're getting pulses of 53.5 volts or so. If I extended the number of floating zeros here, you would see a slight voltage, but it's pretty small. And yeah, pretty cool stuff. So let's go look at that plot. So yeah, looks like the other one with the 2% duty cycle, except there's a bunch of them at 50% duty cycle.